This week's seminar will focus on inequality equations, and the goal for this week will be I can solve, interpret, and graph inequality equations. So now would be a good time to pause the video and title your notebook page as well as write the goal at the top. So this will be your note-taking foldable for this week, and what we'll be looking at first is graphing inequalities, then solving one-step inequalities, and ultimately solving two-step inequalities. So what I'd like you to do is make sure you're taking notes, complete notes on this graphic organizer here, or this foldable I should say, and then this will go into your notebook. So let's get started on this then. So a couple things that we need to look at before we actually get into solving the equations are, well, what do these symbols mean? And what am I going to use when I'm graphing them? And a couple other hints and tricks that we can use in order to help us graph. So let's look at this box down here first. So we have our less than symbol and our greater than symbol. Now, when we're graphing these on a line graph up here, with a less than or greater than symbol, what you're going to have is an open circle. And that will signify that it is less than or greater than. So an open circle when using those. And the reason that we use an open circle for less than or greater than is because in our answer, we couldn't include the number itself because a number would never be greater than itself or less than itself. And that leads us to our next step here then, which is less than or equal to and greater than or equal to. So unlike the less than and greater than symbol, we have to use an open or a closed circle here, to signify that we're including whatever number is in our inequality. So this would be a closed circle. Closed circle when you're dealing with less than or equal to or greater than or equal to. And quickly before we get into graphing these ones up here, the inequality symbols can give us a good insight as to which way our line should be pointing when we draw that in. So if you have a less than symbol or a less than or equal to symbol, your arrow, so these kind of look like arrows here, it will point left. So arrow points left, showing that anything below whatever number it is will make that inequality true. And just like with the less than and less than or equal to, your greater than and greater than or equal to, when you're graphing this, these will point to the right. So arrow points right. Arrow points right. So let's take what we know here from this then, and let's apply it to these inequalities up here. So these are very basic ones. So our first one says x is less than 0. So that would mean we need to use an open circle, and the number that we're going to be at is 0. Now typically you'll draw these right on top of the graph, but in this case today I'm just going to draw it above so that it's easier to see. So if I have x is less than 0, at 0 I should have an open circle since it's less than, and it won't include 0 in our answer. 0 won't make this statement true. And if I look, it's less than, so my arrow should point to the left. So I would draw that in. And that's what that first one would look like. Good way to check to see if you're going the right way is, well, put numbers that are going towards the arrow. So if I put -1 in here, is -1 less than 0? Yes. Is -3 less than 0? Yes. Now we can also look at this here and understand why this is an open circle, because if I were to put 0 in here, 0 is less than 0, that's not true. So 0 cannot be included in our answer here. Everything up to it can be, but 0 itself cannot be. So let's look at these other ones here then real quick. X is greater than 0. That's an open circle again. And our inequality symbol we can think of as an arrow, and it will point towards the bigger numbers, because anything bigger than 0 should make this true. Now the next one here, x is less than or equal to 0, that has to be a closed circle, because 0 can actually be included as an answer. If I would put 0 in for x, it would say 0 is less than or equal to 0. Well, it only needs to satisfy one part of that inequality, and that would satisfy the equal part, that 0 is equal to 0. And if I draw my arrow in here, it's anything less than 0. And then the next one, x is greater than or equal to 0. Well, that would also be a closed circle. Oops, not at -1. At 0. And it's greater than. So it would be anything bigger than 0 to make this true. And like I said, you can put numbers in here to see if it makes it true. Is 2 greater than or equal to 0? Yes. Is 5 greater than or equal to 0? Yes. Is 0 greater than or equal to itself? Yes, it satisfies the one equation. That's why this is a closed circle. So that's just a little bit of a background on graphing inequalities. Now, for the next things that we'll be looking at, such as the graphing inequalities, solving one-step inequalities, and solving two-step inequalities, I'm going to do them on a bigger sheet of paper so that it's easier to see, but I would like you to do these problems within this foldable here so that you have this available to you whenever you're solving these. So, let's look at example 1 in here. So it's the same thing as you can see. Kind of. So x is less than or equal to 3, and x is less than or equal to 3. So we'll just do this on this white sheet here then. So there's nothing that we have to solve on this one. We just have to interpret the inequality that's going on here. So let's go ahead and do that. So if I have x is less than or equal to 3, we have to think back to our foldable here. So we have a less than or equal to symbol. So we're going to need a closed circle, and we'll need that closed circle at 3 because that's what we're looking at. So I'll draw it above, closed circle here, and it tells me that it's less than or equal to 3. So that means, we go back to here, our arrow will point left because of this symbol here. That arrow there kind of looks like it, so it should point left. And that's how you would graph that one. X is less than or equal to 3. And like I said, you can substitute some of these numbers in for x to see if it works. So if I put, let's say, 1 in there, is 1 less than or equal to 3? Yes, it is. Is 2 less than or equal to 3? Yes, it is. We could also put 3 in there this time because 3 is less than or equal to itself. So just a quick check to see if you have the correct inequality going on here. Takes a couple seconds, so I would recommend doing that. Now, I would like you to try example 2 and 3 on your own, and at the end there'll be a spot for you to check your answers. But for time's sake, we're just going to keep moving forward and look at solving one-step inequalities here. So we'll go ahead and work through these. I'll do a couple examples. I'll do 4 from here, and you will be responsible for the rest of them. So, like I said, I'll be doing these on an extra piece of paper. So I'll bring those up here. So the first one we're looking at is x plus 7 is greater than 13. So we'll have to do this just as we would solve a one-step equation. Don't let this inequality throw you off. We can think of this in the same way as x plus 7 is equal to 13. And we'll solve it exactly the same. So if we do that, what we need to do first, and referring to your equation solving foldable might be helpful here if you're still a little bit shaky on that. So what I'd have to do first is undo this plus 7 because I want to get the variable by itself. So subtract 7, these would cancel out, and I would be left with x is, and I'm going to think of this as my inequality now, not an equal, just showing you that you solve it the exact same way even if you have an inequality. So x is greater than 6. Now just like we solve equations and we need a variable equal to a number, we need the same thing here with an inequality, but in this case it should be a variable, some sort of inequality symbol, and a number. So that brings us to the point where we have to graph this now. Now whenever I'm not provided with a graph, what I like to do is draw a line with 5 dashes on it and place the number that's in my inequality in the middle. So 6 would go here. And then I place 2 numbers above and 2 numbers below. So we'd have 7 and 8 and 5 and 4. That just gives us a snapshot on the number line where this will be graphed. Can you do more numbers? Absolutely. But this is probably the best approach here. So let's interpret this now before we graph it. So if we go back and look at this here, we have a greater than symbol. So we need an open circle at 6. Open circle x at 6. And it says x is greater than 6. So my arrow should point to the right because it's a greater than symbol, and it's any number bigger than 6 that will make this inequality true. So to graph that, it would look like that. X is greater than 6. And then like I said, plug some numbers in or substitute them in for x. If I put 7 in here, is 7 greater than 6? Yes. If I put 8 in here, is 8 greater than 6? Yes. If I go off my number line and think further, like 12, is 12 greater than 6? Yes. So this would be the correct graph for this one here. Let's look at example 2 from your foldable here. It's the same thing. X minus 8 is less than or equal to negative 19. So same thing, just on a bigger scale. So let's go ahead and solve this one then. So remember our purpose, what we're trying to do is get the variable by itself. So I have a 8 subtracted here. So in order to get x alone, I need to add 8. These would cancel out, and I would be left with x is less than or equal to, if I have negative 19 and I add 8 to that, I should get negative 11. There's your integer operations again. Like I said, those don't go away. So at this point we have a variable, an inequality sign, and a number. So what that tells me is that we're ready to graph this. Like I said, my 5 number line here, put negative 11 in the middle, 2 above, 2 below, so negative 11, negative 10, negative 9, negative 12, and negative 13 would round out that number line for me. So, now looking back at my inequality here, it says x is less than or equal to negative 11. Let's look back at my notes. Less than or equal to would mean a closed circle at negative 11. So I'll close that up. And then it says less than or equal to. So we have to think, well, which way would this go? Well, we can use the trick of looking at the arrow, and that tells us that it should point left. But if we really think about this, x is less than or equal to negative 11. negative 11. It's anything that's smaller. And keep in mind with negative numbers, smaller means you're working to the left, not to the right. Those are bigger numbers. So we'd have an arrow this way. And here we can plug in some of these numbers as well. Negative 12 is less than or equal to negative 11. Yes, that's true. If I put negative 20 is less than or equal to negative 11. Yes, that's also true. In this case also, we can put negative 11 in here because that makes this inequality true. And that's why we have a closed circle. So negative 11 is less than or equal to negative 11. That's true because it meets one of the criteria. Negative 11 won't be less than itself, but it will be equal to itself. So that's why there's a closed circle here. So that's example 2 on the one-step inequalities. And those dealt with addition and subtraction that we last did, and these next ones will deal with division and multiplication. Kind of like we've looked at with solving equations already. It's the same thing, we're just introducing the inequality symbols. Now, before we actually do these examples, there's one thing we need to make note of, and that deals specifically with multiplication and division. So this is the big rule that you need to remember. Besides the open and closed circles for the symbols, this is the other thing that you really need to remember, and that's this. When multiplying or dividing by a negative number, you must flip the inequality. That's a big rule that you need to remember, because if you don't, then you won't have a true inequality statement. And I'll show you what I mean by this rule here with a couple examples that we'll go through. One thing I did forget to mention is that examples 3 and 4 I want you to do on your own, and at the end when I show all the answers, you can check your answers against that. Same thing with the 2 examples that I don't do down here with multiplication and division. So let's look at these real quick. So I have here 6x is less than or equal to negative 42. Now if you're thinking back to your rules for solving equations, we're basically at the bottom at this point. And in order to get x alone by itself, we need to divide by 6. Because a number next to a variable means multiplication. The inverse operation of multiplication is division. So we need to divide by 6. And just 6, not x. Not 6x, because that would get rid of x and then we'd have a whole bunch of problems going on. So dividing by 6 on both sides, I have these 6's would cancel, making it 1, so I'm just left with x, or 1x, less than or equal to negative 7. Now you might be thinking, well, Mr. Coleman, you didn't flip your inequality. And the reason why I didn't flip my inequality is because I didn't divide the number that's on the right-hand side by a negative number. It doesn't matter that this number is negative. The only time that would matter is if this 6 was negative. Then I would have to flip this inequality. But at this point I don't, because I divided by a positive number. So at this point we have a number and x, I should say, an inequality and a number. That means we can graph. So I should have negative 7 here. Remember, I put my 5 numbers in, 2 above, 2 below. Negative 6, negative 5, negative 8, negative 9. I have less than or equal to. That means a closed circle. So a closed circle at negative 7. And since it is less than or equal to, my arrows should point left, but also any number that's less than or equal to negative 7 will make this equation true. So if I were to substitute any of these numbers into this equation that are less than negative 7, it would make this inequality true. Also, if I were to just put it in this one, that'll work too. Like negative 8 is less than or equal to negative 7. At this point, you're probably getting the point with that. So let's take a peek then here at example number 8. And this one will involve the rule that we just talked about. When multiplying or dividing by a negative number, you must flip the inequality. So I'll show you what I mean. So in this case, we have division going on, x divided by negative 3. What I'll need to do is multiply by a negative 3 on both sides. And when I do that, here's what will happen. Negative 3 times a negative 9 is a 27. Now in my brain an alarm is going off that I multiplied by a negative. Oops, I didn't mean to draw on there. I multiplied by a negative, so I need to flip this inequality. So right now it says less than or equal to. I want it to say greater than or equal to. And the reason why we have to do that is because if we left it the other way, we'd end up with numbers that don't make this inequality true. So then x. So I would have 27 in the middle here if we go over to graph this, because we have a number, an inequality, and x. So 27, 28, 29, 26, 25. I did those the best that I could. You get the point. Now you might be saying, oh, how do I do this? This doesn't make sense to me. 27 is greater than or equal to x. Well, at 27 we need to have a closed circle because it's greater than or equal to. And this is telling me that any value of x, 27 will be bigger than it. So that means my arrow needs to go to the left. And you might be thinking, well, wait, this inequality here is pointing to the right, so why doesn't it go that way? Well, you have to think about what this is really telling you. So that arrow pointing isn't always a true statement. This says 27 is bigger than or equal to any number that you put in here. We could also rewrite this by putting the variable first and then flipping this inequality back because we changed the order. Now it says x is less than or equal to 27. Now this is true. Both of these work. This one's just a little bit harder to interpret. And if you're ever going to change the order, you need to change the symbol. You also might be a little bit confused here by thinking that, well, we multiplied by the negative and flipped the symbol, but we just flipped it back. Well, it's just because how this problem worked out with the variable being on the right side, and we moved it back to the left, so that means we need to flip the inequality back over if we change that order. So just keep that in mind if you're doing anything like that when solving these. So those are your one-step inequalities. Remember this rule. This is a big rule that you need to remember. If you don't, you'll get problems wrong, and I don't want that to happen. So what I want you to do is go back then and do example 6 and 7, I believe, the ones we didn't do. And then you can check those against the answers at the end when I show them. So let's move to let's move to solving two-step inequalities. Now I'm just going to do a couple of these for time's sake, and then I want you to do the rest. These ones are nice and they provided you with the graphs, and as you can see it's set up similarly to the ones that I do when I don't have a graph, with 5 values. Put the number that you solved for in the middle, 2 above, or I should say 2 above and 2 below. So let's do a couple examples here. I'll do example 2 and example 5, and then the rest will be yours for practice before you fix your entry slip. So, example 2, and like I said before, these are going to be solved the same way as if there was an equal sign in here. So this is just really a two-step equation. So let's go ahead and work through this real quick. So what we should do first is subtract 7 from both sides. So those cancel. And I would be left with negative 9x is greater than or equal to 18. Now I need to undo this multiplication with division, so I'd be dividing by negative 9 on both sides. And now an alarm is going off in my head because I've divided by a negative number. That means I need to flip my inequality. So let's not forget to do that. So we'd be left with x is, instead of greater than or equal to, it's less than or equal to negative 2. If we go and graph that, negative 2 in the middle, two numbers above, two numbers below, negative 1, 0, negative 3, negative 4. We have a less than or equal to symbol, so we need a closed circle at negative 2. So we'll throw a closed circle there. And what we'll need to do then is interpret what this says. So it says less than or equal to negative 2. So that means all numbers smaller or negative 2 will make this equation true. Remember, you can think of this as the arrow that's pointing to the left. So our arrow should point left. X is less than or equal to negative 2. So that is example 2 for you there. And let's look at example 5 real quick. And then the rest will be for you to practice with. And yes, you need to do them because practice is important. So looking at this, I have negative 18 plus x divided by 4 is greater than or equal to negative 30. So the first thing I need to do is move any constants that I have. So plus 18 on both sides, plus 18. Cancel. I have x over 4, and it's positive because there's a plus symbol here, is greater than or equal to negative 12. So what I need to do then on both sides, since this is division, I need to multiply by a positive 4, multiply by 4. And remember, just because this 12 is negative, I don't have to flip this inequality. The only time I would flip this is if I was multiplying by a negative 4. So if the number that's with your variable is negative and you have to multiply or divide by that, then you need to flip it. But in this case, you don't. So I'd be left with x is greater than or equal to negative 48. So let's go ahead and graph that quick. Negative 48 in the middle. Two numbers above, two numbers below. So negative 47, negative 46, negative 49, negative 50. So once again, this will be a closed circle at negative 48 because it is greater than or equal to. So closed circle. Now it's saying any number bigger than or equal to negative 48 will make this true. So remember, with negative numbers, those aren't the ones pointing to the left. Those are actually smaller. With negative, it has to go to the right because those numbers are bigger. So your arrow should go that way, to the right. And remember, this shows you that, but you shouldn't just rely on that to understand which way the arrow goes. You should really understand that any number bigger or equal to negative 48 will make this true. So if I were to put, let's go all the way back to 0. If I put 0 in here, 0 is greater than or equal to negative 48. Yes, that's true. So you can test any numbers to see if this makes this inequality true. And I would recommend doing that because that's another good check to ensure that you have the correct answer. So those are just a couple examples from the solving two-step equations. What I want you to do now is go back and solve any of the examples here that we didn't do together. Do the examples in the one-steps that we didn't do together. And also in the two-step ones, do the ones that we didn't do together, and then check them against my answer sheet at the end. And make sure that you're actually doing these because this practice will help you do better on your exit slip. And remember, do all your work right in this thing here. So before we wrap up here, I'll show you the answers to everything. And you might want to pause on each part. Take this out of here. So here's your answers here. Check those. Here's your answers to the top here. And sorry, some of this is small. I can zoom in a little bit more to make it, yep, that works. So double check those. Double check these here. Make sure that your inequality symbol is going the right way. And last but not least, here's all your two-steppers. So then at this point you should have this completely filled out, and this can go in your notebook now. Now please remember to put it in there because these are tools that you can use when you encounter these topics. That's what these are intended for. So make sure you're using them. And just a quick review that today we looked at inequality equations, and our goal is I can solve, interpret, and graph inequality equations. So hopefully after watching this seminar you have a better understanding of inequality equations and how to solve, interpret, and graph them. As always, please ask me questions if you have any.